Thank you for everyone coming to this talk. I will be talking about the behind the scenes of smart contract security reviews, or why we still have hacks. And before I actually begin the presentation, I'd like a show of hands here. Who works in security or tries to reduce the number of hacks we have? Can we see a raise of hands? Okay, we've got a couple in the audience. So for those of you who are looking around, if you're still upset about the state of security at the end of this talk, blame them. Now we have someone to blame. Okay, we can proceed. So today we're going to talk about a few things. We're going to start about the A word. I will explain what the A word is. Then we will jump into a few different mental models that are actually used in auditing, or mental modes. And we'll wrap up by talking about some of the variability that we see in audits. And if you do want a copy of the slides, they're online. QR code is also at the end of the talk. A bit about me. I'm an engineer. I do security. Basically it. yAudit and yAcademy. For any of you who are interested in leveling up your security skills as a developer, we do have free security training, mostly Solidity security, but we are just starting our ZK security track this week. And I used to do Web 2 security and hardware before that. So what is this A word that I speak of that I'm claiming we should not use? It is, in fact, the word audit. Now, for anyone who's heard about security in the Web3 space, you have probably heard of this word. Now, the word audit outside of Web3 security has a certain meaning or connotation to it. You will often find it in tax audit, compliance audit, or process audit. And these terms sound very professional. It has a certain weight to it. You know that something's being done in a certain way, being done properly. And that's because there's certain criteria or requirements that go into the audit process. In these other contexts, we will often find things like checklists, standardized best practices, and written rules, along with certified inspectors or auditors who actually do the process. Now, keep in mind, these are the other contexts. I have not talked about smart contract audits, and that's because smart contract audits are completely different. We will cross most of these out because they don't apply. Really, the one that's maybe relevant is some checklists, but these aren't always applied. It's only when you find a relevant protocol and maybe only an internal checklist. There's no standardized one. We don't really do standardized best practices, written rules, not really there yet in the audit process. And certified inspectors or auditors, I mean, let's face it, when you have certification, that's some form of centralization usually. And centralization, well, we don't do that here. So unfortunately, a lot of these don't apply. And that brings us to the state of security audits today, where basically if you want to be an auditor, well, congratulations, you're an auditor. It's pretty easy. You just say you are. I really wish I had a time machine to go back and fix this, but unfortunately, we are stuck with the term now, or so it seems. If any of you have a time machine, please let me know. We need to fix this, but because we are stuck with this word today, I will be using it in the talk. But just keep in mind that I suggest don't use the A word. That's why I often say I do security reviews, not audits. Okay, so let's jump into the actual content today. And that is to show you some of the behind the scenes in this security process, because let's face it, we still have quite a few hacks in this space. No one likes that. It's real users getting hurt at the end of the day, and that hurts the entire ecosystem. So what's going on where these so-called auditors are getting paid to do security, and it really doesn't prevent the hacks? Like, this seems ridiculous. So let's see what's happening behind the scenes. Today I'll actually pull back the curtain, and we're gonna start by dispelling some of the myths, rumors, and misconceptions around auditors and what they do. Now, first, I'd like to say that auditors, when viewed from the developer perspective, probably look something like this. The auditors swoop in, come with their magical approval stamp, and boom, your code is magically approved with some security dust on top. Unfortunately, this is not what the auditors look like nor do. But then we have the auditors or security professionals viewed from the novice perspective. And the novices probably think the security professionals look something like this. If you have less than 10 monitors, you're doing it wrong. You need to upgrade. But unfortunately, this is also not quite accurate. We do have then the perspective of the security auditors viewed from their parents. And of course, their parents have no clue what this person's doing. It really just, it makes no sense. It just looks ridiculous. And I mean, the computer monitor doesn't even have a power cable. It is ridiculous. He's not doing real work. We all know that. So just doesn't make sense at all. But the reality is a bit more boring. I think this is generally what you will see something happening in the audit process, something like this. We read code, we look at what the code's doing, understand the logic, and maybe even print it out if we want to get exciting. These are actually from crypto Twitter, not my own. But enough about that. Let's actually get a bit into the process. So I'm actually going to give you a unique opportunity today to step into the shoes of the auditor role and try to understand what's happening so that we can also understand some of the issues with the process. Because the process is, as I showed with all those crossed out lines, it's a work in progress, shall we say. I'm going to talk about mental modes. Mental modes is just a way that I have come up with to explain what is happening in the process of an audit. It's the best way I found to convey the information. And to explain mental modes, I'd first like to jump into some assumptions. If you disagree with these, that's perfectly fine. It's just one way that I think about the audit process and security. So if you have someone doing security, let's assume that's quite different from what a developer does. At the surface, a developer is building the code from scratch, and the security person is not looking at code from scratch. They're looking at what the developer created and trying to check if that's secure. So the mindset of building something from the ground up versus looking at something that's created is quite different. I often joke when people ask if I'm a developer, I say, no, I just read code. I don't create it. Different mindset, different skill set. The second point is that many brains are better than one brain. And the idea around this is that if you have 100 security people looking at a certain code base and they don't find any bugs, it's a better guarantee that there aren't many bugs compared to just one person looking at the code and saying, well, I didn't find any bugs. So the more eyes, the more brains you have on your code, the better. And the last point is that if you only have one person, you're resource constrained, time constrained, well, at least one person with many perspectives is better than one person with one perspective. And that's the whole idea behind mental modes, that we are trying to switch our perspective on the code to look at the code in different ways so that we can try to catch some of these bugs that maybe would not be caught with just a single perspective. And I'd like to visualize this because I've just said a lot of words. It might not make sense, but this is how I try to visualize it. So these mental modes are ways of looking at the code like these blue arrows. And when you look at the code, which the code is a black box because I'm an artist, the blue lines try and crisscross the code in different ways, and the red circles are bugs. So if you have your blue line going in the right angle, you look at the code in the right way, you're going to hit a bug, which is one of the red circles. And that's what you want. You want as many blue arrows as possible to crisscross the code in all the ways possible to find these bugs. Now this diagram is a best case scenario. Unfortunately, this is more like the reality. We might have some bugs that we don't catch because we didn't have enough perspectives, enough eyeballs, enough time. And what is the difference between these two? If you're doing an audit, do you actually know which one you're in if you don't have the final answers from the back of the book? You often don't. So it's sort of like a best effort that we're trying to throw as much effort, skill set, perspectives at this as we can. But do we know if we caught all the red circles? We don't. So this is the best visual I have of showing how the process is quite difficult and there's no easy rule sets to apply to the problem. I'm going to explain what some of these blue arrows or mental modes are, and we're actually going to do a few examples. So by the end of today, you're all auditors. You will have the title. Just joking. So first, comparison mode. This mode is my favorite because I'm an engineer. I'm extremely lazy. The less brain power is necessary to find a bug, the better. Comparison mode is finding similar pieces of code and just comparing them, diffing them, find the differences. When you see a difference, then you can turn the brain on and try to ask, why is this code different from over here? What are they doing that's different, and why? Logic error mode is the one that most people would think of for auditing. You are going through the code, each line in detail, trying to understand every piece of logic, and then you put it together and you ask, does this make sense? Is there a problem with this logic? Now finally, bug hunting mode, it's, let's say it's an expedited approach. It's more efficient, it's less thorough, but it's faster. And you're just looking for specific types of bugs. You're really focused on, can I take value from this protocol? If there's a withdraw function, maybe you look, well, can you just call it for someone else's value? Can I take value from user 1 and user 2 and user 3? Because that's bad if you can do that. So bug hunting mode, fast, not thorough. And daydreaming mode, I like to do this towards the end of a security review, of an audit. After you have a good understanding of the protocol, you can switch into thinking, now that I understand this really well, I understand the design of this protocol, what would someone do to try and cause a security problem? And you really need to understand the protocol in the big picture to apply this mode, because you'll see connections between extremely different aspects of the protocol, and you can think, well, if these 3 assumptions apply to different pieces of the code, you can do something. So it's more abstract, shall we say. Let's get into more detailed views of these, because I know that we actually have a rather technical crowd. I'm going to use pseudocode because I'm too lazy to write real examples. But comparison mode, let's actually look at what the auditor is doing in this mode. We have a few functions, and they're doing similar actions. We have a deposit action, we have an underlying value function, and we have a withdraw function. Now, in theory, the deposit and withdraw should reverse what they're doing. And the underlying value, that should be similar to what the withdraw is doing, because withdraw should be taking out the right amount of value. Now, yes, this is a rather silly example because we're multiplying the value by a ratio, but at a high level, we want to check that that ratio, 7/10, is reversed between deposit and withdraw. And we can see that in the first one, deposit, 7 is numerator, 7 is denominator in withdraw, and the withdraw function, the ratio matches the underlying value function. So at a very high level, the math seems to like roughly check out when we just look at the surface level. Now later you'd want to apply logic error mode and like go in detail, try to ask why. Why are they using this ratio? Why 7/10? Does this even make sense? But diffing mode, comparison mode, it's this simple. You look through the code, you find similar actions, and you just check that they match up, that they reverse each other properly, because when you look at these functions not correlated to each other, you can sometimes miss things. So, comparison mode, very convenient and simple. Logic error mode. Now, I know this might be a bit small for you, but if you could all spend 30 minutes reading through this code every single line, then we will discuss. No, just kidding. We're going to skip this one because it honestly just takes too long, but this is a lot of what people think auditing is. It's just one perspective. Bug hunting mode. This one is a favorite of these people who like to appear in articles that they found some amazing bug. They're not really looking at the code thoroughly. They're just focused on very specific bugs that maybe you can withdraw value. That's critical, not good. So bug hunting mode, you would really just look, where are you focusing your effort? You don't want to look at everything. So if I'm looking at these function names, set config, well, it has an only owner modifier. So not everyone can call it. I'm just going to skip it because we're looking for something that any attacker could call and steal value. So skip that. Send to multisig, same thing. I mean, it's not even sending the value to an arbitrary address. It's sending it probably to the multisig, and it has an only owner modifier. Not going to look there. Total assets, it's a view function. It's not modifying the state. You can't actually steal value. I'm not looking at that. Deposit, I mean, that's losing value. You're like giving value to the protocol. I want to take value, so I'm going to skip that. So really, you can skip most of the code, just focus on withdraw, and if you can withdraw value to any address, that's a bug. So that's an example of bug hunting mode. You try and be efficient with where you focus your energy. A quick recipe for finding bugs, and this also gets into a little bit of the audit constraints. This is the view I take when I think about what's happening during the audit process. So if the clock starts at the very start of the graph, the auditors are looking at the code with almost no knowledge of the code base. Sometimes if the code is a fork of another protocol, there might be some knowledge that they already have, but generally you're starting just to read the code of the protocol at the start of the audit. And it's a race. You have limited time. If you had infinite time, you could find all the bugs you want, but we don't, unfortunately. So the race is to try and understand the code as fast as possible so that the developer's understanding is, the auditor's understanding exceeds the developer's on the security aspects of the code. Because the developer knows what should happen, but what should happen might not be what actually happens. So you need to check all of the assumptions, understand all the logic, and see if you can sort of race to beat the developer's understanding before the end of the audit, because that's where you find the bugs. When you understand the code better in the security aspects than the developer, you can find the assumptions that don't actually work or that are incorrect. So this is basically what happens during the audit process, or ideally should. I should say that if you have a massive amount of code and you want the audit done in 2 days, the auditor probably will not exceed the developer's understanding, unfortunately. Okay, not all audits are equal. I think this should be a given that anyone can be an auditor. So you're an auditor, congrats, you're an auditor too. What I just discussed is the time spent with the code is important. If we had infinite time, we would find more bugs. But there's a lot of protocols out there. There's only so many auditors, and let's face it, the Americans say time is money, so gotta spend it wisely, shall we say. So time spent with the code is one important factor, and the skill level of auditors is also important. I'll actually be touching on this more at my ETH Belgrade talk, but that's enough about it for now. And this one is interesting. Does the audited code actually match what is on-chain? This is an interesting problem because if an audit finds a bug and the developers fix the bug, does the code get audited again with that change? Do the auditors only focus on this one change that was made and try to check, is this change good? Is it bad? So this is another interesting puzzle because often if the audit finds something, which is what the audit should do, you need to change a code and then it doesn't match what was deployed. Anyway, interesting problem. And then this final one, for any of you security people in the audience, this is actually a bit of alpha. It's been very useful in recent audits for me, is does the audit consider on-chain values? Normally, the audit happens before the code is on-chain. And sometimes when the code is on-chain and deployed, you will see state variables set in constructors, in initialization functions, and these completely change the assumptions you had when you read the code and you were reading the name of the variable that like, it should be this. And in your head, you're like, okay, it should be that. But then once it's on chain, you see the developer set the value wrong and it's like, wait a minute, that's completely wrong. So sometimes when you look at the code without the proper context, it's missing something. You're not looking at the whole picture. So if anyone is doing an audit and the code is already deployed, highly recommend open up Etherscan or your favorite block explorer and check these on-chain values. Check your assumptions. Very important. Okay. Now, if we think back to that image I showed of the black box with the blue arrows and the red circles trying to find these bugs, it's a process to try and find all the bugs and make sure that your code is bug-free. It's not going to be an instant process of the auditor coming in as a unicorn, giving you a stamp, and you're good to go. That's a little bit of an oversimplification. So these are some concepts I'd like to convey. And you can see that the symbols I use, it's greater than or equal to. So it's not actually a strict rule that 2 audits are actually better than 1, but 2 audits can be better than 1 audit. So if you already have 1 audit and you get a second, it can offer some benefits. Sometimes it might not. We have the idea that like 10 auditors could be better than 2 auditors, not always. And this is one of the concepts that's very difficult to convey outside of this little Web3 security bubble, is that security is not as rule-bound and strict as maybe the development process could be, or some other aspects. It's a rather fluid skill set with some element of art, perhaps, even. A 10-week audit can be better than 2-week. 2 skilled people could be better than 2 junior. But on the other hand, 2 junior people who are extremely focused and driven can sometimes equal, possibly even outdo 2 skilled auditors. So these aren't strict rules, but just things to think about. There's also, I think I've just touched on some of the lack of clarity here. Yeah, so this is basically what I was just describing. We actually can't, when we change multiple variables here, like we have a 1-week audit with someone really skilled, or a 4-week audit by some really junior people, well, maybe the 4 weeks of time actually is better than the 1 week of someone who's really skilled. I mean, it's really hard to say when you're changing multiple variables, which is better. And these are some of the problems that developers have to grapple with when they're choosing to get their code audited. It's a question of like, well, I could do this or I could do that. Which one do I want to do? And unfortunately, I don't have the answers for you. It's a difficult problem. Again, the idea of like 2 audits with really skilled people or 5 audits with more junior people, well, maybe if each audit finds a lot of issues, by the time you get to the 4th or 5th audit, you don't have many bugs. Maybe, maybe not. The same thing with an audit with many findings. Sometimes when an audit report has a lot of findings, it actually distracts from other bugs. There might be more bugs, even though the report has a lot, but it's just hard to focus on everything when there's a lot of things that need changing. Lastly, the idea that a high-risk bug is a high-risk bug is not always true, which sounds kind of crazy, but the risk rating of like, is this a high-risk finding? Is this a low-risk finding? It's very fluid. It's very opinionated. I might call something a medium risk. Other people call it a critical risk issue. Which one is it? It's hard to say, and it also depends on your assumptions. So even just the risk rating of bugs in reports is not standardized. So why do we still have hacks? This is why everyone's here today. We're upset about these hacks. Or maybe it's just me, because I get really annoyed when these happen. I would say perhaps the main reason is still that unfortunately some deployed contracts don't have a thorough security audit. Note the word thorough. You can have an audit, it might not be thorough, different things. Everyone's an auditor. Issues can be overlooked with the wrong mental mode. This goes back to that diagram with the blue arrows. You can miss bugs. I've missed some bugs. Standard processes do not help for novel bugs. There's always new stuff happening. I think that's the only constant in Web3 is change and new things. So sometimes you don't know about it because no one's found it yet. And yeah, lastly, this space changes fast. The merge altered some MEV stuff. Smart contract languages are changing. I don't even know what version of Solidity we're on now. I think a new one just came out. So yeah, lots of change. So I'm going to quickly summarize again. So remember the A word. Everyone is an auditor. Be careful with that word. It doesn't mean what you think it does. Different perspectives and mental modes are very helpful for finding bugs. You want to crisscross the code, find these red circles, and do it as much as possible. That's how you find the bugs. Lastly, more effort and time is more security bugs. Remember the graph. the graph of auditor knowledge increasing above developer knowledge. And finally, security effort is not easy to measure, and we still have difficult decisions to make. I do have empathy for developers trying to choose which audit option is best because it's a difficult problem and we don't have easy answers for it. So with that, I am done with the presentation. Thank you very much. Hvala vam.